Bismillahirrahmanirrahim. Now we begin our discussion on the modern uh, OPC model, OPC Unified Architecture or OPC UA. The classical OPC model, DA, AE, and HDA were widely accepted and implemented across the industries. However, they had a few limitations. These old ones, they were having some they had some limitations. So it's better before we start, we will go through them. So one major limitation was about the area of information modeling. Information modeling. Right. So classical OPC models offered disaggregated data. Disaggregated data with no context. Okay, so they handle only the basic data types like integers, Boolean, and timestamps, which made it difficult to represent complex systems like the software structures or the physical devices in a meaningful way. So, however, since there is no metadata to describe what a variable means, the client has to figure it out on its own. So what we were missing, we were having like no meta data. So we were having no metadata. Okay, so no metadata. So client needs to client has to figure out client needs to figure out at its own um, about all these data sets. So that increased the complexity. So lastly, the DA and AE and HD interfaces, they actually work independently. So all of these, they actually work independent. Okay. And so that means there is no built-in way to relate the different type of data together. And this correlation must be handled manually by the client. So the burden was on the burden on client to deal with or to find the correlation, to deal with the relation or between these DA, AE, and HDA models. So that's why OPC UA was developed to overcome these limitations. Um, Next, we will see a few more limitations. So continuing from this previous slide, now we look at two more limitations on the classical OPC and what motivated the development of OPC UA. So the first is about the dependency on the proprietary technologies. So classical OPC was tied closely to the Microsoft Windows, relying heavily on the COM and DCOM technologies. This restricts the so that restricts the cross-platform compatibility and also the flexibility. Okay. So secondly, there was a serious issue on security and the robustness concerns. So the DCOM based communication is hard to configure. DCOM is very hard to configure, and especially when dealing with the firewalls. And it's also not sure by today's standards, and it also lacks the encryption mechanism and authentication. Okay, so here the key points are uh, the configuration and the encryption, and also the authentication issues. Okay, so because of all these challenges in 2001, the OPC Foundation began working on unified and modern standard. So in 2001, the OPC Foundation, they began to work on to bring a unified and modern standard to overcome all these limitations that we discussed. And in 2006, around 5 years, after 5 years, they achieved this through OPC UA. So this is the major milestone it is like a major uh, milestone in the industrial communication protocol, right? Okay, so this diagram illustrates how the OPC UA functions in a real industrial environment. Real industrial environment. Okay. Okay, so on the left side here, we have the field connections, and we have the field connections, which includes the various hardware, that includes the instrumentation, Modbus, the PLCs, DCS, and Profibus, all of them. And these devices are connected to the OPC server. All these devices are connected to the OPC server, um, and the OPC server actually collects all the data. It collects all the data, and it collects all the data from the field devices, and it exposes to the high level applications. And these servers can be provided by they can be provided by the vendors themselves, the hardware vendors, or by independent software solution providers. Okay. On the right side here, we have the OPC client, and these may include the HMI, the SCADA, the edge server, and diagnostic tools like this is UA Expert is like a diagnostic tool, and even the enterprise or EMS MES systems. So these clients, they consume the data. They consume the data from the UA server for monitoring, control, and the applications can be control, monitoring, uh, monitoring, and the other things can be like Yeah, so they can do the monitoring control, and it is the whole thing is it is the whole thing is that we have now as a key point we have the standardized, secure, and platform independent, platform independent way of like data exchange, way of data exchange. Okay, and this is ideal, and this scenario is basically ideal for IIoT based plant architectures. Okay, so in this slide we show the interaction between the OPC UA clients and OPC UA server using a secure and standardized communication flow. The OPC server is responsible for collecting and providing the data to the clients, and it can be developed by the hardware vendors, and hardware vendors or the independent software solutions. And OPC client is basically the applications like the HMI, SCADA, even the Raspberry Pis, UA experts. So these clients actually send request. So actually they request they send request to the UA, the OPC servers, and the OPC servers they actually respond back with the necessary data. They can also read and write. Okay, they can also read and write as to the server as needed. So some key characteristics of the OPC servers are listed here. So for example, it uses certificate for secure and trusted communication, ensuring that the it is authorized clients can connect. For it shows that authorized clients are able to connect, and then uh, and all the communication is basically encrypted. All the communication is encrypted, which makes the OPC UA suitable for this makes it suitable for secure industrial networks. OPC UA is not just a protocol. It is basically a platform independent standard. It is like a platform independent standard that supports the Linux and even the web architecture, the cloud and IoT devices. It also supports, this is very crucial about this point, that it supports the complex information model where all the properties, values, the set points, the units, and configuration, everything is bundled together and sent to the clients. So, and further, the feature like auto populate and the scalability, they make it ideal for like scalable or for expanding the system. Okay, so this is ideal for expanding the systems. So in essence, basically OPC UA offers what it offers is like a robust OPC UA I should write it here. So it is offers what it offers. It offers reliable, robust, and flexible architecture. For and further, the architecture is there, and it gives us like scalability, and also the standardized, secure uh, way of industrial communication. Okay. Okay. So next, right. So now we will go a little bit deep. This slide shows uh, a comprehensive overview of the unified architecture, and by combining like the conceptual. So this is the conceptual. Uh, this is the conceptual model, and this is like on this side we have the uh, technical sort of block diagram. Okay, so we will go and spend some time here on this slide. So let's start from this top left diagram. Uh, at the center, it mentions clearly that the OPC UA basically inherits the client server. It inherits the client server architecture. Okay. Now from here on the like a clockwise way, we will try to understand how it is going. So the client connects to the server and it makes a remote call. Okay, so it makes a remote call to the server for read, write, or subscribe to the data, and then the communication stack then converts these protocol calls into the secure messages, either binary. These are the messages, either binary or text, to travel over the network. So from here, the messages will be on the network. Now on the server side, this is the server side again. So on the server side, this communication stack is decoded, just like anything on the network. So it is decoded, transforming them back into the procedure calls that the server can understand and act on it. Then the server replies. Okay, server replies. Um, or notifications are processed and sent back through the same stack, but in the reverse order. And finally the server organizes all the data and metadata into the structured space. Here every data is ready in this structured space. Okay, so all the data that is requested goes to a structured space, exposing this data back to the client. Okay, so where it can see nodes and other attributes. So now looking at the block diagram, technical block diagram on this side, what we see here on top is this is the client. Here we have the client on top, and the client's we call it client supervision application, which sends requests, and you see the client is sends the requests and it receives the replies. It is sending the request, it is receiving the replies here. Okay, and it is further managing the subscriptions, and also it handles the notifications here. So all these messages are managed by the UA communication stack here, this one. And this communication stack is labeled through, for example, A, B, C, and D. So what is A? A is basically, yeah, A is our request message. B is our reply message. C is our subscription message, and D is our notification message. So all these messages are here, and the communication happens over the supervision network. All the messages over the supervision network reaching the UA server. This is the UA server here. And inside the server here, inside the server, what we see is we see a address space here, space address, this one. So in this is space address, it holds the an organized nodes and views. So what we see here is we have nodes and we have a view. So the nodes and view to represent each variable or the object is managed here in the space address. We have a subscription manager here. This subscription manager monitors the specific items and generates the notification as values change. So the data is is ultimately comes from these field devices. Data is traveling from here, but this whole data which is coming from the PLCs, DCS, or the field buses, so it is coming to this architecture. And this architecture not only ensures that it is platform independent and scalable, but also provides like we can say that this whole thing is in a sort of a semantic context. Okay. Okay. So this slide introduces the concept of the address space in the OPC UA, which is a fundamental part of the information model capability of the OPC UA. So OPC UA address space is structured in a hierarchical structure, meaning it's organized more like a tree. Okay, so the structure is more like a tree, and each element of the system, such as like we have the devices, the sensors, the actuators, and the methods also, they are actually represented as a node. Okay, so everything is basically represented as a node, and these nodes are basically interconnected using references. So we have nodes, and the nodes are connected through references. So we will have nodes, and these nodes will be connected. Here, another node, and this node will be connected through some kind of references. Okay, and this allows the server to express the relationship between the elements, for example, like parent child, functional association, or dependency links. So each node includes properties which are basically called attributes, and these attributes define the metadata. So the attributes are basically defining these attributes actually define the metadata. Uh, okay, so each node includes properties which are called attributes, and these attributes define metadata like names, values, status, and the reference is essentially a link. So the reference is basically like a link or a pointer between the two nodes. Okay, so each reference will include a few things like source node, target node, reference type, and also the direction. So there are like four things in which the reference will be will have. Okay, so it will have like this source node, the target node, the reference type, and also the direction. So these four things are actually included in the references. In this diagram, what we see here is in this diagram. Okay, so in this diagram, we see we see node 1, and this node 1 has multiple references, they pointing to node 2 and also to node 3. Okay, so this node 1 is connected to node 2 as well as node 3 through multiple references. You see that we have no reference number 1, reference 2, and reference 3, and it is further connected with the node 3 through reference 4. Node 2 and node 3 are connected through reference 5, and then we have another self reference for the node 3, reference 6. So this structure gives us a standardized machine readable format for the clients to explore the server's data model. So in short, the address space is what all allows the OPC UA to be not just a communication protocol, but it provides us like a semantic sort of model that helps enable the better data operability and the uh, and browsing through the automation. Okay, now let's more talk about the how the nodes are modeled. So each node belongs to a specific node class depending on its function, and these node classes define what kind of data or the structure a node represents. So for example, some nodes are instances. Okay, some nodes are instances, and like temperature value, or while others are types like the definition of a sensor. So the key node class in OPC UA is like it's a variable, the method, the object, or the view. So in case of the variable, this is the most common one. It is the common most common type of node, um, most common type, and it represents a value, like for example a pressure or a temperature reading. Okay, and the clients can read, write, and subscribe to this node to get the update. Okay, so the clients can read, write, and to get the update. The method node is these nodes define the methods, callable functions. Okay, so these are like callable functions, callable, and they take the, just like a function, they actually take input, and then they provide some output parameters and are used for executing actions. Like for example, if we want to open a valve, okay, so like open a valve or start a motor, okay, or some kind of a run a calculation, okay, do some calculation. So these methods are invoked by the clients using a call service. Okay, so they are basically, clients are the ones which invoke this method. Then we have the object node. So this is like a structured element, and it helps to organize, mainly to organize variables and methods together. Okay, for instance, a motor could be modeled as an object that contains a speed variable and a start method. We will see in the next slide. Next, we have view. View helps filter what a client sees. Instead of sending the entire address space, the server can expose just a subset of the nodes relevant to a specific client or application. This we will see in the next slide. This improves the performance and clarity, and so the overall OPC UA modeling capability allows, like, the overall capability is quite rich. Okay, so this information model allows us to have quite a rich and flexible representation of the industrial system. Of the industrial system. Okay. With each node class playing a unique role in the transformation model. So the nodes are playing a key role in this information model. Okay. Next. Okay. So now let's look at a simple, but it is really a powerful example of how OPC server structures its address space. Okay, so on the bottom part of this figure, what we see is a server side structure. So this is the server side structure. Server side structure, and on top we have a client side view or structure. So on the server side structure, it contains what we see. It contains a lot of nodes. Okay, and we see a lot of nodes, and each node has a you see it has a class, and it has a display name. Okay, so node has a class, and it has a name, display name, NAME. Okay, display name, and some other attributes as well. And it has some other attributes like description and the value. We begin with a view node. So we start with this view node, and this view node is called area 1, and this view is designed to organize and simplify what a client sees. So what a client sees is dependent on this node. It references other nodes. We see these lines are references. This is how it is referencing the other nodes, such as M1. This is the M1 motor 1. This is an object node, and this object node represents this one. We are talking about this node. So this node represents a motor, and contains several components. So it has like speed, it has this torque, it has the stop and start. Okay, and these are either like variable nodes. We see the type. So this is like a variable node here. This is also a variable node here. Okay, like speed and torque, and they actually carry the actual values. And it also has the method nodes. So these are the method nodes. And these two are its variable nodes. Okay, so this we can run through remotely. Okay, so we can execute remotely. Okay, so for example, the speed node, speed is a variable node. This is the speed. Speed is a variable node with the value. So this is the value, or it is 2980 RPM. And this torque node, the value is let's say 0.6 Newton meter. And these nodes are also labeled with a description, so the clients know what they are interacting with. On the top of the diagram here, we see the client's view. This is the client's view on top, and this is a mirror of the exposed parts of the address space. So this whole address space, of the server side, it is neatly arranged through this view node, and it shows how the things are arranged. So it is organized neatly under, if you see it is neatly arranged like under area 1, then the motor 1, and then finally the leaf nodes are here. Okay, leaf nodes are here. So this visually highlights that this is how why I was saying that this is tree like hierarchical nature of the OPC UA address space. Address space. Okay, right. So in short, this example gives us a very clear picture of how OPC UA maps out the real elements like motor and control interface into structured accessible nodes. Okay, let's a brief description here also. This is the last slide about this. So in this slide, it continues the same example, okay, how the address space works in the OPC UA, focusing on how the motor M1 is modeled. So basically, M1 model is modeled. M1 is modeled in using OPC UA. Okay, and first we see that the motor M1 belongs to the view node, which called the area 1. This view is useful for filtering and organizing the server's address space in a logical way for the client. And the motor itself exposes to two other variables like speed and torque, and the two methods is start and stop. So what we saw is we have motor 1. Okay, this is the motor. Okay, this is motor 1, and then this motor 1 has a view node in the view node, and it has further two variables, uh, two variables. Okay, the speed and the torque. Okay, and also it has the two methods. Okay, so start and stop, and these are basically the two methods. Okay, so the motor itself exposes two variables, speed and torque, and two methods, start and stop. And the variables provide live or historic data like how fast the motor is running or how much torque it's producing. The method represents the executable commands to turn the motor on and off. Now, remote clients such as a SCADA system can connect to the server, and so any SCADA system, it can connect to the server, and through server it can browse the nodes. Okay, and you can, for example, you can filter by view. Okay, you can filter by view and read or write, filter by view, read and write to those elements. They can change the motor's speed or retrieve the values even for the past. So one of the key things to highlight is how the reading operation can be done. So the reading operation can be done in the synchronous way or asynchronous way through the callback functions. And in asynchronous way, it is based on the callback function. So this flexibility supports the different industrial needs. So also clients can dynamically add or remove nodes within the view, but they cannot delete the view itself. Okay, so this helps in maintaining the structured integrity of the overall address space while still enabling the flexible client interaction. So this address space is a crucial element, and that's why we need to discuss this in detail. Thank you very much. The next will be OPC, some examples on OPC UA server and client implementation examples. So I will stop here. Thank you very much.